Okay. As mentioned in the previous video, now we're going to look at how to find domain and range from algebraic expression. Let's take the example of 2x plus 1. How do I find domain and range? To answer that, first understand what an invalid input means for a function. Why? Because remember, the definition of domain is a set of all valid inputs. So what's invalid in math? If you have a calculator lying around, or you can use your phone or use the internet, try and input these operations: 7 divided by 0, 10 divided by 0, or 0 divided by 0. What happens? What does that mean? So you should get an error, a syntax error or division by 0 error, one of those depending on what instrument you're using. This is an example of what we call an invalid input, which means that the division by 0 is not defined. Why is it not defined? Well, here's the first possible project idea. Is look at this function given by f of x equals 1 over x. What is f of 0? Clearly, if I plug in 0, it doesn't work, right? You've already checked that. What about, let's be a little smart about it. Let's not plug in 0, but plug things that are very close to 0, like zero point 0.1 or 0.01 or 0.0001. What's the f of value for this? You can use a calculator. What about numbers that are negative and also close to 0, like negative zero point 0.1 or negative 0.01, negative 0.0001, right? Further, you can then explore, well, what happens if it's 1 over x squared or 1 over x cubed or 1 over x to the 4? A possible project idea you can think over, do a presentation on what happens and what 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 do you think about it. Try and not use the internet for this and see what you can explore just by finding these values and see what conclusions you can draw. It should be an interesting exercise. What else is an invalid input? Well, there's lots of them, but for now we're going to restrict to these two: division by 0 and square root of negative numbers. A little disclaimer here: square root of negative numbers only when we are working with real numbers. So later on in this course, we're going to say that you can take square root of negative numbers. And we talk about imaginary numbers and complex numbers, but that's much later in the semester. For now, we're going to restrict to these two invalid operations: division by 0 and square root of negative numbers. So let's go back to the function we started with, 2x plus 1. None of those arise here. How do I know that? Well, A, there is no fraction, so denominator cannot be 0. B, there is no square root, so I cannot have square root of negative numbers. What that means is domain is everything, negative infinity to infinity, and the range is also everything, negative infinity to infinity. Here's a concept check for you. Draw the graph of this function based on what we learned in the previous video and verify that you should get the same domain and range by looking at the graph. Next example is 1 over x, which is the starting point for the possible project idea. We're just concerned with the domain here. Clearly, we cannot have x equals 0 because it's a division by 0, so the domain cannot contain 0. Every other number is fine. You can plug in 1 over 10, 1 over 100, and you can conceptualize, well, I can divide 1 by any number I want, positive or negative. All I cannot do is divide it by 0. Now, here's a notation alert again. We've been writing negative infinity to infinity with round brackets to mean all the numbers. Another way to do that is write it as capital R with an extra vertical line, which means all real numbers. Okay. So here, because we are saying that everything except 0 is okay, what we're going to write it as is R minus, in curly brackets, 0, which means all real numbers except the one number 0. Or you can draw a number line and make a hole on 0. Remember, making the hole means you're removing 0 from the possible values. Or you can say that's component A and component B put together, which is negative infinity to 0, union 0 to infinity. This union symbol here, U for union, means OR. So you're saying that the domain can be any input in the region A or in the region B. So we use union when we talk about ORs, right? So if there are disconnected regions in your domain. Let's see. I think I have a few examples here. Okay. Try this problem, pause the video, find the domain of 1 over x plus 2. Okay. Here's the thought process. Always check, is it possible for the denominator to be 0 or there to be a square root? There's no square root, but there is a division here. So I see, let's check if the denominator can be 0. So we back calculate. So if I want the denominator to be 0, that means I want x plus 2 to be 0, which means x must be negative 2. So I have to remove negative 2 from my domain. So domain becomes r minus negative 2. Or you make the number line and plug a hole at negative 2 because that's not included. Or you can use the union notation, negative infinity to negative 2, union negative 2 to infinity. Now, an example which includes square root, find the domain of square root of x minus 7, which is not equal to square root of x minus square root of 7, okay? We saw earlier that square root of negative numbers are invalid. So we need whatever is inside the square root, we need that to be positive or greater than 0, which means it must be, x must be more than 7. You can try plugging in. If I plug in x is like 3, 3 minus 7 is negative 4, problem. 6, 6 minus 7, negative 1, still a problem. What about x equals 7? Well, 7 minus 7 is 0. The square root of 0 is 0, which is okay, because 0 squared is 0. So the domain is going to include the 7, but not include infinity. Yeah, because general, we never include in negative infinity and infinity because they're not really numbers, so they cannot be included. It's just a concept. That's the end of that, and you have one last video for this week, which is going to talk about algebra of functions. That's coming up next.